Good morning. Welcome to my presentation about China Institute Problematic Internet issue. First, we will have a look at the data. Here, you can see the drilling dataset had 3,960 samples and 82 features, including the ID column and the targets SE. Now we move to the missing value. All the columns had a substantial proportion of missing value, except ID and three basic demographic columns for sex, age, and enrolled season. Here as you can see, even the SII had the missing values. But this is the world trailing dataset. If we only count the missing value on the first usable part of training dataset, the chart will slightly different. Now we move to the information. Here we can see the distribution is imbalanced. There are 1,594 samples on zero, but only 34 on the third. If we compare the training dataset to the testing dataset, you will see that there are any PC IIT in the testing data. The purpose of this is to avoid using directly the column because it would make the problem too easy to solve and not suitable for practical machine learning goals. Now we come to the demographics. The participants are between 5 and 22 years. Here you can see there are twice as many boys as girls. Now we come to the student enrollment. The four student of enrollment had similar frequency. Now come to the target distribution. According to this, you can see that boy has slightly higher risk of internet addiction than girls. And that a brief overview about the training dataset. Now come to our group submission. The the point on the left is a private score and on the right is public score. This is the first version. In the first version, I only select four features. Here I use train test split to split the data into two parts, training part and testing part. About the missing value, I fill the missing value on target Y with the value which appear most, and the missing value in feature X I use simple immutable to fill with mean. Here I use random forest classifier to train the model, and the final result I got is only 0.073. Now come to the third person. In this version, I still select only four features and use the same way to split the data here, and the same way to handle the missing value. Here I use Smooth to deal with the data imbalance, and in this version I use voting classifier with the combination of three models: random forest, XGB, and 9BGM. Here I use the output. I use the output probabilities of each model to calculate the final prediction with the train. The with the train, the private score I got is 0.212. Now we come to the 9%. Is it person the number feature I select is 11, but I still use the same way to split the data and handle the missing value and data imbalance. Compared to the third parent, here I use one hot encoder. It's, and I use the PCI to reduce the dimension, and I create three interactive feature through. And in this version, I use the voting classifier with 7 models: random forest, XGB, 9GBM, cache boost, logistic regression, gradient boosting, EVC. With the, therefore, my result rise to 0.236. This is the 17th version. In this version, after refactoring the public code, I made some improvement in the code such as here, using many features with many groups, and I also use the time series feature. Compared to the next version, I use simple emitter to handle missing data. I and I don't perform dimension reduction or data normalization. In this version, I use three separate models: neural forest, logistic regression, and XGBoost. After that, I combine them using ensemble voting classifier model. The private score I got is 0.339. And now come to the 22 version. I still use the particles with some edits. The code has process file function to process take time serial file from directory. Use the log time serials function to merge static into a data frame. They also use the encoder to encode time series data and reduce the time series data dimension. In this function, they create additional interactive feature from the original feature. In this version, they use KNN imputer to replace missing value based on average of last 5 rows. Here, they replace infinity value with none. Now, come to the train ML function. In the function, they split the dataset into 5 subsets using stratified K4. The else split is 5 here. After that, they had a loop to change the model after X4. Then they optimize prediction thresholds and make the final prediction. Here you can see I use a simple immuter to handle the missing value in data. This version I use voting regressor with file estimator like GVM, XBoost, cache, zero forest, and gradient boosting. And the final score I got is 0.445. That was presentation on China is still problematic in internet use. Thank you for listening.